In this question, there's a 4.6 kilogram sled which is being pulled across a smooth ice surface. And when the question says smooth, it means frictionless. The force acting on the sled is of magnitude 6.2 newtons and is pointing in the direction 35 degrees above the horizontal. So for example, something like that. So this would be 35 degrees. This force is 6.20 newtons. So let's just draw the other forces. We have the weight force. Remember, this W is equal to mg. And then we have a normal force perpendicular to the surface. Let's draw our force chart. We have forces and the x and y components. Let's look at our pulling force, which is the 6.20 N force. So what's the x component of it? The x component would be this part right here. This is our x. And as you can see, that is the cosine component. So that would be 6.2 cosine of 35 degrees. And it's positive because it's in the first quadrant. And the y component is the y component here, this part right here, would be 6.2 sine of 35 degrees. And then we have our weight, no x component, y component is negative. Instead of writing a number, I just wrote negative w here for simplicity. And the normal force, again there's no x component, but there's a positive y component there. So next up, once we write this, is to add up. This is sigma, which is the sum of all the forces. So x component is 6.2 cosine of 35. And in the y component, it would be 6.2 sine of 35 minus w plus n. Let's look at Newton's second law, F equals ma, in the x direction. As a rule of thumb, if the system is moving in the x direction, in this case it is, it's good to start with the x direction. So fx, so this is the sum of all the x components, which is right here. So we have 6.2 cosine of 35 degrees equal to the mass, which is 4.6 kilograms, times the acceleration in the x direction. And this gives us ax equals 6.2 cosine 35 divided by 4.6, which is about 1.10 meters per second squared. So that gives us the acceleration. And the question is, if the sled starts at rest, how fast is it going after being pulled for 1.15 seconds? Now it has become a kinematics question. So what do we have? We have A equals 1.1 meters per second squared. Sled is starting at rest, so our V0 is 0 meters per second. And our time is 1.15 seconds. So if we use V equals V0 plus AT, we have 0 plus A, which is 1.1 times 1.15 seconds. So V is 1.27 meters per second.